Hey everybody, this is Professor Monty, and today what we're doing is we're jumping into section 10.5. It's called Inferences for Two Population Means Using Paired Samples. Now we're going to be doing all the computations with StatCrunch, so we'll be doing all of those on the computer. Now, notice we're looking at two population means again like we did last time in 10.2 and 10.3, although in those sections, one of the requirements is that we had independent samples. So the selection of one sample couldn't have anything to do with the selection of the second sample. Well, this is just the opposite. The selection of the second sample is directly related to the selection of the first sample. So in this case, the two samples have a natural pairing. In other words, they are not independent samples. And so remember, we're looking at two populations. And so we've got two populations. We're picking a sample out of each population, but the samples are not independent. So let me give you a quick example of what I mean by that. Maybe we're looking at the heights of a father and son pair. And we want to say, hey, is the height of the father different than the height of the son? Well, those have to be paired together. Clearly, those can't be independent because once we pick the son, the father, he only has one biological father. Okay, so another idea like that is maybe we're looking at life expectancy. And that could be of people also, but let's say I have a washer and dryer. So the washer and dryer are going to be in the same household. So by doing something like that, we get rid of any external influences, any environmental thing, any way that the washer and dryer are handled differently because they're handled by the same people. So we can look to see, you know, is there going to be a difference in these? Another one, and this is very common that we'll run into, we're looking at the same person, but for instance, before and after a diet. If we want to know if this diet works, we want to look at a specific person. How much did you weigh before? How much did you weigh after? Do you weigh less after? If yes, then maybe this diet works. But it has to be the same person. So those are ideas of what we'll do. We'll do a couple examples so that you get an idea of it. But what we're doing in this case is we look at average difference of each pair. Now what we're going to call that is D for difference, but it's the average of the differences. So we're going to call it D bar. It comes from the sample. And we'll say trying to determine if there is a difference and that D we're going to call capital D in the paired population means. And so let me show you an example of what we're talking about. A lot of this is going to be invisible to us because what we're doing is we're going to use StatCrunch and it's going to do all the numbers for us. Let's not put that over there. Let's move that over. Nope. We'll cut that and we'll move it back over here. So we've got it in a nice spot. All right. So let's do that. But here's what we're doing. Notice they've got 10 different couples here. So each couple is a pair. And look at that first couple, the husband, 59 years old, the wife, 53 years old. If we take the difference in their ages, we see that that's 6 years. So what we end up happening, that last column of differences, this column right here, That's our data. So we only actually have one column of numbers. This is going to be a t-test. It's not going to be a two-sample t-test like we did in the previous sections with independent samples. We're looking at just that one column of numbers and saying, okay, that difference, and then we'll say, hey, is that greater than 0? Is it less than 0? Is it not equal to 0, depending on what we're looking for? And there's one of two ways they're really going to show this. So the null hypothesis, often the way I like to do it is d is equal to 0, because that makes no mistake that, hey, we're just looking at the differences. We're not really looking at the population means. Although I will tell you, sometimes you will see it listed as mu1 equals mu2 or mu1 minus mu2 equals 0. To me, that's a little confusing because I can't tell from looking at the null hypothesis that that's different than looking at actually the average of the two populations with independent samples like we did before. But regardless, we'll do it however they present it to us. I will go with the d equals 0, and then the d either not equal to 0, greater than 0, less than 0, depending on which one we want to do. And then it can be similar to the mu's as well. So we'll just look and see which, on our problems in StatCrunch or our problems in MyLab, which way they present it. Okay, so we'll just say one of these. Okay, so that's the idea. Let's look at the assumptions for this test. So the first one is we do have to have simple random paired samples. And this is very strict. You definitely have to have that. The other one is what we always see, normal, this time they'll say differences. Or large samples. Oops. That's not cleaning up very well, is it? Large samples. And we usually do n greater than or equal to 30 for large samples. And that's the pairs. We'd have to have 30 pairs or more, of course. Okay, and the normal difference or large samples, this test is pretty robust. So if that's off a little bit, that's okay. It'll still be able to handle real well. Okay, so we've got that. Those are our assumptions. I'm just going to jump in and do a couple problems. So let's go into StatCrunch and see what we have in there. I've got problems 16 and 17. All right, so here's problem 16. It says the null hypothesis. Now notice they're doing the h sub 0. The null hypothesis is mu1 equals mu2 instead of d equals 0. That's the way. Sometimes you'll see it that way. Again, not my favorite, but you will see it some way, sometimes that way. So again, this could have been written as d equals 0. Okay, and the alternative hypothesis is mu1 is greater than mu2. So what they're saying is the first group, maybe like those ages of the husband and wife, they're saying, hey, I think the husbands usually are older than the wives. Let's test that. And so that's the type of thing they're doing here. The data in the accompanying table are from a simple random paired sample. We're in good shape. From the two populations under consideration. Use the paired t-test to perform the required hypothesis test at the 10% significance level. So we know alpha is 0.10. So we can go from there. Okay, so find the test statistic, use population 1 minus population 2 as the difference. Well, let's look at our data. So let's click here, we'll look at the data. Now notice there's only 8 pairs here, so we must be assuming that it's normally distributed. I don't see it says anywhere there, but it tells us to use the paired t-test, so that assumption must be in there. All right, so here's what we do. Now notice population 1, population 2, we're not adding up all the population 1, we're doing population 1 minus population 2. So 7 minus 3, 22 minus 25, 19 minus 16, etc. And just looking at those differences. So the way we do with those, we just go straight into StatCrunch. We're going to open it up. And in StatCrunch, could not find data. Well, that's not very helpful. Let's try that again. Let's click out of there. Try to do it again, see if it'll do it. If not, we may have to enter the numbers ourselves. Let's see. Come on, could not find data. Very much not helpful. All right, I'm going to do this one more time. I'm going to actually take a picture of the data with my phone, and I'll show you if we run into something like this, we may have to do this type of thing. So I'm going to take a picture, and then I'm going to enter the data in myself. So let's try one last time. Let's see. Open in StatCrunch. Yeah. I think it heard me, got scared, and said, all right, I better give them the data this time. So, but we would enter the data just like we would in into an Excel file. Okay, so I've got the data in there, I've got the pairs. Notice population 1 is listed, they named them for us. So what I do to do it, I go into stat, T-stats, because it's a t-test, and I go into paired. And it says, oh, okay. They say, okay, help me out a little bit. Where is sample 1? I say, oh, that's population 1. What about sample 2? Population 2. And I'm doing a hypothesis test. Remember, we're assuming it equals 0 versus greater than 0. And so we'll just go compute it. Again, if we had the confidence interval, we'll just click down here instead. So let's compute. The things we're going to need, they're asking for the t-value. And notice we have a t-value of, let's see, t is 0.1607. I don't know how many decimals they'll go, so we'll go that far. The p-value, I'll list here, is 0.4384. All right, so we'll come back to that in a minute. All right, we don't need our data anymore. It says t rounded to 2 decimal places. Okay, to 2 decimal places, we have 0.16. So let's go ahead and enter that in. Determine the p-value to 3 decimal places. Well, 0.438. All right, we got that right. Now, let's talk about how we interpret this. Because remember, here's what we do. We look to see if this is less than or equal to, over here, 0.10, which is our alpha. We see that clearly that's not less than or equal. So what we say is do not reject the null hypothesis. And if we can't reject the null hypothesis, remember the null hypothesis was that mu1 might equal mu2, or that the difference, there is no difference, the difference is 0. So our conclusion in terms of the alternative was, hey, is the difference greater than 0? Remember, that's what this would have been. The alternative hypothesis is the difference greater than 0. We're going to say do not reject the null hypothesis. No, there is not sufficient evidence to say, and then either d is greater than 0 or mu1 is greater than mu2. The second way in this problem, again, I prefer that first way, but when we look at our answers, now we can go look at it. What is the correct conclusion? Do not reject H sub 0, the null hypothesis. There is not sufficient evidence that mu1 is greater than mu2. So we click on D. I like to write it out, first of all. Even if you're not writing it out, think in your head the conclusion. Don't go and read the answers and say, which of these could be the right conclusion? If you've figured out the right conclusion first and then you go look, it's going to be much, much easier for you to get the right answer. Okay, so let's go to the next question. It's the very next one that I had picked out. So Let's look at this one. So this one, we have to set up the whole hypothesis test ourselves, and it's a little bit different. This is one of those before and after problems. Anorexia nervosa is a serious eating disorder, particularly among young women. The data available below provide the weights in pounds of 17 anorexic young women before and after receiving a family therapy treatment for anorexia nervosa. Does family therapy appear to be effective in helping anorexic young women gain weight? So right there, that's pretty important. That's what we're asking. Preliminary data analyses indicate that use of a paired t-test is reasonable. Okay, so it had to be the two assumptions were fulfilled. So there had to be simple random paired samples and either normal differences or large samples. Well, they said there's only 17 pairs, 17 young ladies that they tested here. So there had to be normal differences. Okay, so let's look in. So did they gain weight? Well, let's talk about the null and alternative hypothesis. The null hypothesis is that mu1 is equal to mu2. So weight before is the same as the weight after. Again, difference equals 0. Or the alternative, now if they gained weight, that must mean mu1 is less than mu2 because they weighed less before. Okay, so they weighed less before, they weighed more after, they gained weight after this family therapy. Okay, so let's look, pick out the right one. So let's see, mu1, it's not A, it is B. All right, so let's go from there. Find the test statistic. All right, so again, and let me clear all this off so that we have room to run the test. Let's go ahead and run the test. We'll open it up in StatCrunch again. Okay, so before and after. Notice they're not saying these are paired, but it's before and after. They have to be paired. These can't be independent samples if they are before and after. So we'll open it up in StatCrunch. We'll do a quick look. Hopefully it'll open up the data this time right away. Could not find the data. That is not helping me out. I don't want to enter all this data by hand, but we will if we have to. We'll give it 3 chances just like last time. Hey, second chance worked. Okay, so let's go in stat. Again, t-stats paired. That's it. Before minus after. And let's go look. And this time we would get less than. Compute. All right, so this time we get a t-stat. So our t-value, negative 3.6252. And the p-value, we'll list it down here so we can do our test, 0.0011. Okay, let me erase that. All right, so let's jump back out of this, back to my problem. I don't need that anymore. So my t to 2 decimal places. What did we get? We had negative 3.63. All right, so we got that right. The p-value is what is this? 3 decimal places, 0.001. I am not in the right spot. There we go. There we go. 0.001. We got that right. Okay, now the conclusion. Again, let's go through the conclusion, see how this works. So here's what we say. We say the p-value less than or equal to, well, we have to find the significance level. There it is, 5%. 0.05, that's alpha. Well, this, if I move it 2 decimal places, is 0.1%. So this would be 0.1%. Clearly that is less than or equal to 5%. So we say, I don't want to write in that box, we say reject the null hypothesis this time. Because if it is less, we reject it. That means there's almost 0 chance. There's 0.1% chance we would get these data values if the null hypothesis were true. So I say, well, that's so unlikely. I don't think the null hypothesis is true. So we reject the null hypothesis and go with the alternative and say, yes, it does appear, or the data does provide sufficient evidence that the difference is greater than 0, or the way our authors saying it, mu1 is greater than mu2. In other words, that on average, the young ladies gained weight after family therapy. So let's see. So what is the conclusion for the hypothesis test? Reject the null hypothesis. The data provide sufficient evidence at the 5% significance level that the mean weight increased after therapy. After therapy is greater. And so that's it. That's the idea. Try these out. Stick with these. I think you'll get them pretty quickly, but realize the big change this time from what we did prior is these are not independent samples. They're paired samples. And so we look at it just as a single t-test, not as a two-sample t-test. So do it as a paired t-test in StatCrunch, and I think things will go real well for you. All right. So hang in there and, just keep working through it, because this is all stuff that the more you do, the better you get.